Have you ever wanted to adjust a low battery indicator to appear as a defined state of charge for a certain battery type? Or wanted to know how much capacity a rechargeable battery loses after a given number of cycles? It is important to understand and test the characteristics of your battery at various points in a charge cycle. Significant data can be collected by monitoring voltage and internal resistances against the charged and discharged capacity of the battery. Rohde and Schwarz provides a tool supporting battery data collection and analysis. The batteries can be repeatedly charged and discharged while collecting information about open circuit voltage, loaded voltage, and internal resistance, depending on the charged and discharged capacity. The tool provides a variety of charts for displaying the collected data, and can also be used for characterizing battery samples and creating battery models, which can be used in battery simulations. In this video, we will explore the capabilities of the battery cycling tool by utilizing the Rohde and Schwarz NGU201 power supply, connected to a nickel metal hydride AA battery cell with alligator clips. This tool comes with several unique features to assist in the compilation and analysis of data from battery cycling. The Remote Control tab has information about the remote connection, instrument information, a communication field to send commands and queries, and an environment field which links the program to file storage. I will now connect to my instrument. Now we can set parameters for our cycle measurements. This tab consists of three main fields: global settings, highlighted in purple, discharge settings, highlighted in orange, and charge settings, highlighted in blue. Here you can set the number of cycles and if you would like to start and end with a charge or discharge cycle. If a battery is connected where the charge state is unknown, start your measurement with the charge cycle and click Prepare. You can also enable what charts you would like to see generated and specify which channel or channels you would like data collected from. The NGM power supply can utilize this tool on two channels simultaneously. Charging and discharging can be done with constant current and pulsed current. For both methods, the open circuit voltage of the power supply can be set. However, the internal resistance can only be determined with pulsed charging. For this reason, a battery model can only be created from pulsed charge or discharge data. The charge end criteria serves the purpose of protecting the battery from overcharge. The configurable charge end criteria supported are voltage, voltage plateau, negative delta V, low voltage, capacity, and time limit. Multiple criteria may be selected. With the pulse charging method, all criteria related to voltage can be applied either to voltage under charge or the extrapolated open circuit voltage. Once completed, the settings configuration can be saved. While a cycle is running, the Dashboard tab shows an overview of the battery state. Live updates of minimum, maximum, and average readings for power, instantaneous voltage, and current are updated on the instrument. From the voltage difference and current difference, the internal resistance is calculated. Energy and charge are also featured updates on this display. While the battery is cycling, the data is written into a log file. This file can be accessed in the Post-Processing tab to analyze the data. It is possible to display charts of various values versus charged or discharged capacity, or versus number of executed cycles. The central button on the display allows for selection of cycles from which traces should be generated in the chart. The Create Battery Model field allows you to turn logging data from battery cycling into a battery model. The first number in this file is the state of charge percentage. followed by the corresponding open circuit voltage and internal resistance. For a battery model generated from discharge data, the battery capacity is always determined from the discharge data of the same cycle. For a battery model generated from charge data, it is possible to select whether the battery capacity should also be determined from the charge data, or instead from the discharge data of the same cycle. Understanding and testing the characteristics of your battery at different points in a charge cycle is critical. Today we discussed the battery cycling tool by Rohde and Schwarz, which supports battery data collection and analysis. The configurable settings for the tool features allows for a wide range of battery types to be tested. We saw how the tool provides a variety of charts for displaying the collected data. We also saw how it can be used for characterizing battery samples, as well as creating battery models, which can be used in the battery test. For more information, please view the full application note on our website.